In this video, we are going to continue with revision of mathematics paper 1 for 2022 GCE. Now, here we are continuing from question 17, and we'll consider this one as the part 2 for this paper. Now, we'll have the question 17a. In the following diagrams, A, B, C, and D are points on the circumference of the circle center O. BD is the diameter, so whenever we have a diameter, this means that we are going to have two semicircles. Then AD is equal to AC, and angle BDC is equal to 22 degrees. So let's look at the questions that we have. So find BAC. So BAC, so this angle here. So this is the angle that we are looking for the first one. Now we can see that BD is the diameter. So whenever we have a diameter, this angle is just equal to 90 degrees here. So that is the use of the diameter. We have an angle of 90 degrees. Then CBD. So we have CBD. CBD is this angle here. Now, if here we have an angle of 90, so is this angle. Now, how do we find this angle? So if we are to redraw the diagram, it's like this. So we have a right angled angle here. Then we have this 22 degrees. So how can we find this angle here? So for us to find this angle here, we need to subtract 22 from 90, because we know that these two angles adds up to 90. So what we are going to do here, you just have to say 90 minus 22. So 90 minus 22, we are getting 68. So this is our answer. Then ACO, this angle here. So how can we find this angle? So we know that the distance OD is radius, and the distance CO is also radius. So if we are able to find the angle ACD, we'll be able to find the ACO. So how can we find this angle? We know that if this angle is 22, BDC, then even here we are going to have 22, since we have the angles in the same segment are equal. So we can see that we have the same angle. So then we know that this angle, the total angle here is 90. So if this is 90, we know that here we have 68. Then we know that if we are to draw an isosceles triangle, if we are given that these two distances are the same, then the base angles will also be the same. So we're going to have x also here, x. So let's find the value of x. So it's x plus 68 is equal to 180. X plus x is equal to 2x plus 68, 180. So if we now collect the like term, so this will be 180 minus 68. So 180 minus 68 is 112. Then we divide by 2, then x is equal to 112, not 66 but 56. So this means that this angle here is 56. Even this angle here is 56. Now if we have 22 here, so we are going to subtract now 56 minus 22. So we are going to get 34 degrees. So this is our final answer. Then we go to question 18. Y varies directly as x and inversely as the square of z. So since z, the relationship of y and z is inversely, then we are told the square. So since we have the square, then our z must be raised to the power 2. So let's make an equation so that we can find the value of k for question A. So whenever we are making an equation, so this will be y is equal to, so in as soon as we've introduced our equal sign, then we are supposed to introduce the constant of variation. Then this k will multiply with x, then over the z will be on the denominator, since it is the inverse. Now we can now do substitution, so we can see that our y is equal to 8, k is what we are solving for, x is 4, over z is 1 squared. So we know that here this is same as 1. So 1 times 1 is 1 times 80. We have 80 is equal to k times 4. We have 4k. So over 4, we know that now the value of k is giving us 4 into 80 will give us 2. Then let's solve for question B. Now for question B, we want the value of y. So the equation is y is equal to kx over z squared. So what's our k is 2, x is 9, over the z is 3 times z, 3. So we know that we have, so instead of multiplying 2 times 9, I'll just let it be like 2 times 9 over 3 times 3. We know that is 3, so that I can just cancel the 9s. Then y is equal to 2. Then for question C, value of z when y is equal to 3 and x is equal to 54. So the equation is y is equal to kx over z squared. So what's our y? Y is 3. So y is 3, x is 54, k is 2. Then we have 54 over z squared over 1. We cross multiply. So 3 times z squared is 3 z squared. Then here we have 2 times 54. So we divide by 3. Then we'll divide by 3. So we know that 3 can go into 54. 3 into 3 is 1. 3 into 5 is 1. Remainder 2. 3 into that is 8. Into 24 is 8. So 18 times 2 we have 36. Then we can now find the square root. So the square root of 36 is plus or minus 6. Now we can move on to question 19a. Solve. We have x raised to the power 1/3 is equal to 9. So how can we solve for 9? I mean for x here. So we need to find the reciprocal of 1/3. So the reciprocal of 1/3 is 3/1, which is same as 3. So whatever you do on the left side must also be done on the right side. So this will be same as 9 raised to the power 3. So now that this will cancel, then we have x is equal to, so it's 9 multiplied by 9 times 9. So we know that 9 times 9 is 81 times 9. So 9 times 9 times 1 is 9. Then 9 times 80. So 9 times 8 is 72. So the final answer is 729. Then in the space below is an incomplete flowchart for calculating height of a cylinder given its volume V and the radius R. Complete so the formula for volume of a cylinder is equal to pi r squared h. So if we are to make, since we are solving for h, the subject of formula, we'll divide by pi r squared, also here by pi r squared, so that if we cancel, we'll have h is equal to volume over pi r squared. So the input here is volume is input, radius is also the input. Pi cannot be the input because it's a constant. So we have start here, we need to put the input. So you say enter, so we'll enter radius, then volume. Then for the second one, we'll just say calculate. So we know that height is equal to volume over pi times radius times radius. So that's our answer for that question. So we go to question 20. Points A and B have coordinates 2, -3, 7, 9 respectively. Find the length of AB. So we are looking for the length of a straight line. So it's 2, -3, x1, y1, then we have 7, 9, x2, y2. Now for the length, the formula is distance is equal to the square root over x squared minus x2 minus x1 squared plus y2 minus y1 squared. So let's do the substitution. So our x squared is 7 minus 2 plus y squared is 9 minus -3. So now let's simplify. So 7 minus 2, we have 5 squared plus here we are going to have it's negative times negative, so we have +3 squared. So 5 squared will give us 25 plus 9 plus 3 is 12. 12 squared is 144. Then if we add 25 plus 144, we get 169. The square root of 169 is 13. So since it's a distance, we just have to put units. We don't know whether these were centimeters or meters. Now let's look at the question B. Given that y is equal to 4x cubed minus 3x squared plus 5x, find dy over dx. So we want to differentiate this equation. So let's write our original equation. So y is equal to 4x raised to the power 3 minus 3x squared plus 5x. So we are going to use the power rule. So we are going to differentiate dy with respect to x. So what we are going to do is we're going to move 3 to the front of x, then we subtract 3 minus 1, then we repeat the pattern. So 2 will go in front of x, then we subtract 1 plus 5. The derivative of x raised to the power 1 is just 1, so we just bring 1 down, then 1 minus 1. Then we know that if we expand 4 times 3 will give us 12x. 3 minus 1 is 2. 3 times 2 will get 6x raised to the power 1 plus 5 times 1 is 5 raised to the power 1 minus 1 is 0. So 12x minus 6x plus what is x raised to the power 1 is 0 is 1. So 12x squared minus 6x plus 5 is our final answer. We move on to question 21. So write down the 3 inequalities that define the unshaded region R. Okay, so we'll consider this as inequality number 1, then we'll consider this one number 2, we'll consider this one number 3. So first begin with the inequality number 1, since it is just touching the x-axis only. So say 1. Now here we do not have the number, so look at the coordinate. So this coordinate here, we can see that the x value is 7, even here the x value is 7. So this simply means that at this point we had a 7 here. So say x cutting the x-axis at 7. Then we have to look at the region of consideration, so it's unshaded. So the unshaded is less, the shaded is greater. So we want the less, so we put less, and we are not going to put the equal, less or equal to, because the line is in the dotted point. Then let's consider inequality number 2. So for inequality number 2, we can see that it's slanting. So here we need to first look at the coordinates for this line. So consider this point. Now this point, we can see that it's 1, 1. So this 1, 1 will be used to both of these two inequalities. So for this, we'll say 1, 1. Then here we also have 7, 7. So whenever we have this, we need first to find the gradient. So the gradient is y2 minus y1 divided by x2 minus x1. So what's our y2? y2 is this one, 7, minus y1 is this one, 1 over x2 is 7, x1 is also 1. So 7 minus 1 is 6 over 6. 6 into 6 will just give us 1. Now since we have the gradient, now we can solve for equation. So y minus y1 is equal to gradient, open brackets, x minus x1. Then y1 is 1, gradient is 1, then x1 is also 1. We know that if we multiply 1 times x is x, 1 times -1 is just -1. Then we shift this number to this side. This will give us y is equal to x minus 1 plus 1, which is y is equal to x. Now here we need to replace the equal sign with the inequality sign. So let's look at so the above region is greater, the lower is less, so we want the lower, so we put less than or equal to y. Now we can now look at the last one. So for the last one, we are going to use 1, 1. Then we are going to use this pair, 7, 3. So the same, we'll begin by finding the gradient. So the gradient is y2 minus y1 over x2 minus x1. y2 is 3 minus 1, x2 is 7 minus 1. So we know that 3 minus 1 is 2 over 6. So if you reduce, we have 1 over 3 as our gradient. Then the equation is y minus y1 is equal to gradient, open brackets, x minus x1. So y1 is 1, gradient is 1 over 3, x1 is 1. So first we have to get rid of the fraction so that we reduce the work. So multiply everything by 3. So this 3 multiply with y will give us 3y, minus 3 times 1 will give us 3. Then 3 times 1 over 3, x minus 1, this 3 will cancel, giving us x minus 1. Then what you do here, we collect the like term, so this number will shift to this side, giving us positive 3. So 3y is equal to x plus 2. So we divide by 3, we divide by 3, we divide by 3. So y is equal to x over 3, or same as 1 over 3 x plus 2 over 3. Then our final answer, we need to put the inequality, so the above is greater, then we have the lower part here, so put greater than or equal to x over 3 plus 2 over 3. Then for question 22a, the components of the vectors OA and OB are 2, 3, and 4, 3, 4, 2 respectively. Write down BA as a column vector. So let's see, we can see that the origin of these two vectors were O. So consider this point as O. Then we have here is our A. Then the vector for A is 2, 3. Then we consider this line as our B. Then we have 4, 2. Now we want to find a vector AB. I mean, instead of AB, but BA. So we want to move from B to A. Then the directions of the arrows were like this. So for us to go to vector A, first we move vector BO plus C or A. So let's do that. So say BA is equal to BO plus OA. So BO is negative. Since we are going against the arrow, is negative 4, 2 plus C. This one is just 2, 3. So we know that we are going to have negative 4, or should be, sorry, not the fraction. So make sure I don't make this mistake. These are not fractions. So negative 4, negative 2 plus 2, 3. So our final answer, negative 4 plus 3 is negative 1. Negative 2 plus 3. Why am I making mistakes? So negative 2 plus 2 is negative 2. Then negative 2 plus 3 is negative 1. So this is our final answer. Then for this question, find the coordinates of point A and C. So we are looking at the x-intercept of this parabola question. So how can we find the coordinates? So we can use the quadratic formula. So let's say x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So let us arrange this equation in order. So we'll start with negative x squared minus c 2x plus c 3 is equal to 0. A, B, C. So A is the coefficient of x squared, which is negative 1. B is negative 2. So say minus 2 plus or minus. Then here we have negative 2 squared plus C. We have 4. Then what's our A? Negative 1. What's our C? 3. Then divided by 2 times negative 1. So negative times negative, we have positive 2. Negative 2 squared, we get 4. Then here we have negative times negative. This will give us positive 12 over negative 2. So x is equal to 4 plus 12 is 16 over negative 2. Then x is equal to 2 plus c. What is the square root of 16? 4 over negative 2. Then we are going to separate. So 2 plus c, 4 over negative 2. 2 minus 4 over negative 2. So x is equal to, here we have 6 over negative 2, which is the first value of x is equal to negative 3. Then here we are going to have 2 minus negative 4 is negative 2 over negative 2, which is giving us positive 1. So we are going to have negative 3 comma 0, 1 comma 0. So you can see that A is on the negative party, so A will be negative 3 comma 0, B will be 1 comma 0. Then the turning point, so we want to find the turning point of the graph. So the equation, we know it's negative x squared minus 2x plus 3 is equal to 0. A, B, C. So the x coordinate of the turning point is negative b over 2a. So it's negative 2 over 2 negative 1. So x is equal to negative times negative is positive over negative 2, which is x is equal to negative 1. So let's see if this is making sense. So the turning point is somewhere here, is where the curve is turning. So we can see that it is on the negative part, so it's making sense. Let's find y. So y is equal to 4ac minus b squared over 4a. So what's our a? Negative 1, c 3, negative 2 squared over negative 1. So 4 times the negative 1 times 3 is negative 12 minus 4 over negative 4. So negative 12 minus 4 is negative 16 over negative 4. Negative into negative is positive. Here we have 4. So turning point, the coordinates will be negative 1 comma positive 4. Then the last question, we have this question here. The diagram, the following diagram is the speed time graph of a car. Calculate the acceleration of the car during the first 5 seconds. So the acceleration, this point is our final velocity. Then here we have initial velocity. So the acceleration is equal to final minus initial over t. So the final acceleration is this number 20 over the initial is 0 over time 5. 20 minus 0 is 20 over 5. 5 into 20 will give us 4 meters per second squared. Now find the value of t given that the total distance traveled was 550 meters. So we can see that we have the shape of a trapezium. So here, this is our distance A. Then from here up to here, we have B. Then this is our height. So the formula for distance is equal to half A plus B multiplied by H. So distance, we have it. So where there is D, we put 550 is equal to half. The distance for A is the distance from 5 to 25 is 20. Plus C, the distance for B is from 0 up to here, we only have T. The height is from here up to here, so we have 20. So we have 550 is equal to 2 here is 1, 2 here is 10. So we have 20 plus t times 10. So instead of expanding, we just say we divide by 10. Also, we divide by 10. So that we have 20 plus t is equal to, here we get 55. So if we collect the like terms, so if 20 move to this side, we have 55 minus 20. So the value of t is 35. So here we have 35. Now let's look at calculate the average speed for the whole journey. So average is equal to total distance divided by total time elapsed. So total distance we are given is 550 over the time taken is 35. So let's see, we can now reduce. So 5 into 5 is 1, here is 1. So 5 into 550 is 110 over 5 into 35 will give us 7. So how many times can 7 go into 110? So in 35 we have 5, another 35, 10. So it's 15. Remainder 5 over 7 meters per second. So this is our average speed. So that's it for this video. Thanks for watching.